Okay, so this is going to be our question number 2, and so we need to use implicit differentiation to find dy by dx and d square y by dx square at the point 1 comma 0 for y square plus 1 equal to x e power 2y. So first I'll write the function. Function of fx is y square plus 1 equal to x times e power 2y, and we need to calculate dy by dx and d square y by dx square. So first, for calculating dy by dx, what we'll do, we'll just differentiate this function. And now this is not a normal kind of differentiation. We are basically doing differentiation with respect to x on both the sides. So here I'll use the power rule here. So this will become 2y, and then differentiation of y with respect to x, so it will be dy by dx, plus differentiation of 1 is 0 equal to, now at this step we'll be using product rule. So it will be like first we'll keep x constant and we'll differentiate e power 2y, then we'll keep e power 2y constant and we'll differentiate x. Now again I'll just write this 2y dy by dx equal to x time. Now differentiation of e power anything is like e power x is e power x only, but here we have a constant number multiplied with the variable, so it will just come down. So differentiation of e power 2y will be 2 times e power 2y. So this will be 2 times e power 2y, and then we'll again write dy by dx because this was a function of y. This e power 2y was a function of y. So dy by dx and then plus e power 2y, and then we'll differentiate this, and this will be differentiation of x with respect to x will be 1 only. So we'll have 1. Now I'm going to rearrange this equation. So basically I'll take this whole term on the left hand side, so it will become 2y dy by dx, but we need to keep this equation because for calculating d square y by dx square we'll be continuing from this equation only, but to calculate dy by dx at 1 comma 0 I am going with this step. So I'll just take, this will be 2 times x e power 2y dx equal to e power 2y. Now I'll take dy by dx common, so this will become, this is 2y minus 2x e power 2y, and this will be e power 2y. Now I'll divide both the sides with this these two terms or this expression. So I'll just divide both the sides with 2y minus 2x e power 2y. This one also. So finally I'll get an equation for dy by dx. This will be e power 2y over minus 2x e power 2y. Now we need to calculate this at point 1 comma 0. So for at x equal to 1 and y equal to 0, we'll just substitute x equal to 1 and y equal to 0 in this. So this will become dy by dx at x 1 comma 0 is e power 2 times 0 over 2 times 0 minus 2 times 1 times e power 2 times 0. Now e 2 times 0 will be 0 only, and e power 0 will be 1. So this will be 1 over, this will be 0, 2 into 0, and this again e power 2 into 0 will be 1 here, and this 2 into 1 will be 2. So we'll get minus 2 in the denominator, and this is the solution for, so the value of dy by dx at 1 comma 0 for this expression or this equation is negative of 1 over 2. Now we'll using this value also in later steps. So we have completed half of the equation. Now I'll continue with this equation. Which one? I guess we'll continue with this one. So I'll just rewrite this 2y. Is it a better idea? Okay, let's just do one thing. We'll continue with this one. So this is 2y dy by dx. I just take a shortcut. Just a minute. I'm just copying this equation. Now I'll again differentiate this equation with respect to x, and now we'll have some kind of special treatment for this dy by dx term. So basically, when we differentiate, then 2y is taken as another function and dy by dx is another function. So we'll use the chain rule between 2y and dy by dx, or the product rule between 2y and dy by dx. So first we'll keep 2y constant, and this will be differentiation of dy by dx is nothing but, I'll just plus, now dy by dx is kept constant, and we differentiate 2y with respect to x. And again this okay, so we'll do this in another step, and this will be now x e power 2y. Here also we are going to use the chain rule, but here we have three functions. Let's say first one is 2x, then we have e power 2y, and then the third one is dy by dx. So I'll keep the first I'll just differentiate the first one. So this will be, or it is better to keep 2 outside the differentiation. So e power 2y dy by dx, and this will be dx by dx plus we'll keep dy by dx and x constant, so x times dy by dx times dx of e power 2y plus, I'll keep these two constants, so this will be x times e power 2y and differentiation of dy by dx, and this will be d dx of e power 2y. Now I'll just start with the differentiation process. So this is 2y, this will become d square y by dx square. D square y by dx square plus this will be differentiation of 2y will be 2, and this will be 2 times dy by dx, and we have one more dy by dx. So I'll just write this stepwise. So this will be 2 times dy by dx equal to 2, and then this is e power 2y. So this will, we have dy by dx, and this differentiation of x is 1 plus this will be again x times dy by dx, and this will be 2 times dy by dx, and then plus, and this will be x e power 2y d square y dx square, and then this will be plus 2 times e power 2y now I'll just multiply this dy by dx, or um, instead of doing that, let's just keep the values. So we have the value y is 0, and dy by dx we calculated for 1 comma 0 was negative of 1 over 2, and then x was 1, so let's keep the values here. So this will become 2 times 0 times d square y by dx square plus minus 1 over 2 into 2 into minus 1 over 2, 2 times e power 2 into 0, and this was minus 1 over 2 plus x was 1, this was minus 1 over 2, and this was 2, and this was again minus 1 over 2, then plus 1 e power I should have a e power this this should be, yeah, okay, I should have one e power 2y also, 2y. Yep, so this will be e power 2 into 0, and here we'll have x is 1, e power 2 into 0, and dx square, this is plus 2, and this will be e power 2 into 0, and this was negative of 1 over 2. Now I'll just go for, so this term will be gone because this is 0, and 2 can get cancelled, this will be 1, and this 2 can get cancelled, this minus minus will become plus, this minus and minus will become plus, and this will go to 0, sorry, this will go to 1, and this will also go to 1, this 2 and 2 get cancelled. So let's see at the end what we are left with. So this term is gone, this will be 1 over 2, then 2 times this is this will be negative 1 over 2, this will be minus minus cancel, positive 1 over 2, again this term will be 1, so this is positive 1 over 2, and these both will equal to 0, and plus we have 1 times d and this will be minus of 1. So I can add 1 on both the sides, and okay, so after adding, this will become 3 by 2 equal to this, and this will get cancelled. 2 times d square y dx square, this will become, just divide both the sides with 2, 3 over 4. So this should be the answer given here. So finally we have also completed the second part. So for first part, dy by dx was negative 1 over 2, and d square y by dx square is 3 over 4. Now I'll just check the solution given by junior tutor also. Okay, so they have also done the same thing, and yep, they are also getting the same answer, so I can just say that correct solution. Good work. And this was question number